For this one, we have y double prime minus y equals hyperbolic cosine of x. All right. So what's the first thing that I need to do? All right. So we're going to find our complementary solutions. All right, so whenever you solve, you get what? You get imaginary solutions. You get m squared minus 1 equals 0. Wait, no, you don't get imaginary solutions. So you get m squared equals 1. So m is equal to plus or minus 1. So c sub 1 e to the x plus c sub 2 e to the what? Negative x.
You said it's okay to leave it like that. This is really far along. Instead of bringing negative x to the bottom, make it positive. Like having c sub 2 over e to the x instead of e to the negative x.
Oh yeah, I would always leave all of my powers of e in the numerator. That's just kind of standard. We usually won't move those unless there's some reason that we could move them to maybe help us cancel some things out. All right, so using variation of parameters, what all do we need to solve for now? Now we have our y sub 1 and our y sub 2. So I want you to do the Wronskian of those. Alright, so we got 3 Wronskians to do. And I want you to do Wronskian sub 1. And Wronskian sub 2. Alright, now, what would a Wronskian be equal to? Yeah, negative e to the 0 minus e to the 0. So that's negative 1 minus 1, negative 2. Alright. So what about here? Negative e to the negative x times hyperbolic cosine of x and then here we have what? Alright, so here's the point where when we start doing our use of ones, finding our use of one primes here and use of two prime, where either you can use technology to do these integrals, or I can go a little deeper into hyperbolic cosine. And I don't mind doing that really quick. It doesn't take that long to do. So we know that use of one prime is Wronskians of 1 divided by the Wronskian. So that's negative e to the negative x hyperbolic cosine of x divided by negative 2. All right, so those cancel out. And then y sub 2 prime is Wronskian sub 2 divided by the Wronskian. So that's going to be e to the x hyperbolic cosine of x divided by negative 2. Now, hyperbolic trig functions are defined in terms of e to the x. So this would be something that if we'd have spent a little more time on hyperbolic trig functions, I would have shown you that hyperbolic cosine of x is equal to 1/2 times e to the x plus e to the negative x. Hyperbolic sign is defined similarly. It's just a little change of positive and negative signs. All right, so that's how hyperbolic cosine is defined. And you can, so now we can just make that substitution in there. We can just plug that in for hyperbolic cosine in both places. So I have a 1/2 here already. So I have 1/2, and then when I plug that in, let's see, I have an e to the negative x. And if I plug in this now for hyperbolic cosine, I'm going to have another negative 1/2, and then I'm going to have e to the x plus e to the negative x. All right, so that's going to be 1/4. And now simply take this e to the negative x and multiply it into those two terms. So what would that give you? If you multiply it times e to the x, add the powers, that's going to be e to the 0. So that's just 1. And then you multiply it times the last term, add the powers, that's going to be plus e to the negative 2x. So you see, it's not actually that bad. It's just that we didn't spend a lot of time on it in Cal 2 because that was something that in the past Mississippi State has said we don't spend really that much time on it either. So that's why I just kind of breeze through it. All right, because you can always look it up if you need it. So for the next one here, we have negative 1/2, and then if I plug this in, I'm gonna have that other 1/2, and I have e to the x. That's gonna be times e to the x plus e to the negative x. So that's going to be negative 1/4 times e to the 2x plus 1. So to solve for use of 1 and use of 2, I integrate those. And those are really easy to integrate. So use of 1 is going to equal the integral of 1/4 times 1 plus e to the negative 2x. And so that's, again, that's really easy. Use of 2 is going to be the integral of negative 1/4 times e to the 2x plus 1. And both of those are respect to x, of course. That's the only variable we have. So this is going to be 1/4 times x, and then what? Minus what now? All right. And then this other one here is going to be negative 1/4 times 1/2 e to the 2x plus x. Alright, so that's 1/4 x minus 1/8 e to the negative 2x. And that is negative 1/8 e to the 2x minus 1/4 x. So that's my use of 1 and my use of 2. Do y'all remember now what I have to multiply those times? Y sub p is equal to u sub 1 times y sub 1 plus u sub 2 times y sub 2. So y sub p is equal to, there's my u sub 1 times, what was my y sub 1? Yep, if you go up here you can see y sub 1 was e to the x. So I have to say both of those terms times e to the x plus, I have this thing here, and my y sub 2 was e to the negative x. Alright, so now let's multiply those in and see if we have any like terms we can combine. A lot of times that'll happen. Stuff's going to cancel out, stuff's going to combine here. So that's 1/4 x e to the x minus 1/8 e to the, if you add those powers, that's going to be negative 1x. Alright, and then multiply there. It's going to be minus 1/8 e to the positive x. Right? Because this one had a positive power. And then minus 1/4 x e to the negative x. So you do have two terms that'll go together, or a couple terms, right? Let's see. Do we? I thought we would have. But we don't, do we? I don't know. Do we? Yeah, you just got a lot of terms you don't have nothing that would, a lot of times we will have stuff combine or cancel out there, but I guess we don't here. It's because some of them have e to the x, some of them have e to the negative x. Alright, so my general solution is y equals c sub 1 e to the x plus c sub 2 e to the negative x. It doesn't matter the order we put them in. Plus 1/4 x e to the x minus 1/8 e to the negative x minus 1/8 e to the x minus 1/4 x e to the negative x. All right. Is there another from that section that any of the 5 of you that have started your homework had trouble with? Number 5. Again, this is variation of parameters. Well, I've done the hard part, right? Just kidding. So now we need to find all of our Wronskians. Well, I'm going to do the regular old Wronskian first. All right. So that's just going to leave me with e to the negative 3x. Excuse me. Here. All right, and then Wronskians of 2. Now we can find our use of 1 prime and our use of 2 prime. I'm probably not want to leave that like that. So, I mean, you could have 1 over e to the negative 3x. That's the same thing as e to the 3x. So, again, it's 1 over e to the negative 3x, but you bring it to the top, it becomes e to the 3x. So then you can put those two terms together. So that's just going to be negative, and then we got e to the 2x over 1 plus e to the x. All right, so now let's find our use of 2 prime. So this one's going to be similar because we divide by that e to the negative 3x. And so that will be like multiplying by 1 over e to the negative 3x, or multiplying by just e to the 3x. All right, so now let's do these integrals. One of them looks really easy. One of them we're probably going to have to think about for a minute. Try to problem solve with it. So u sub 1 is going to equal to the integral of negative e to the 2x over 1 plus e to the x. That's going to be the tough one. U sub 2 is the integral of e to the x over 1 plus e to the x. That's going to be the easy one. That's a natural log integral. Alright, because if I let my denominator be my u, my du is e to the x, it's in the numerator. So it's the integral of 1 over u. Alright, we might have to get a little creative here. The only way that comes to mind, like really quick for me to try here, is to see if I can make this into a by parts integral. The reason why I say that, and I don't know if it'll work or not, is because if I could make this equal to, this would be the negative integral of e to the x times e to the x over 1 plus e to the x. Alright, and so if I let the most complicated part of that I can integrate be my dv, the most complicated part that I could integrate would be this. I don't know if this is going to work, but we can try. That's just what comes to mind. So let's see. So I'm going to have the negative integral of e to the x times e to the x over 1 plus e to the x. So then I would have to let my u equal e to the x and my dv equal e to the x over 1 plus e to the x. So then my du would be e to the x, and my v would be natural log absolute value of 1 plus e to the x. The only problem with this is I don't know if I'm going to be able to do the resulting integral from my by parts formula, but I can try. So remember, it's uv minus the integral of v du. So this is going to be uv would be e to the x times natural log absolute value 1 plus e to the x. All right, and then minus the integral of e to the x times the natural log absolute value of 1 plus e to the x. All right. So what can we try now? I mean, I'm just going to... I was thinking that, but I was also thinking that if I let this now be my u, then my du would be e to the x, which is present. So if that's present, then I'm really just doing the integral of the natural log of u. And I know for a fact that I've shown y'all how to do that integral. So this is just going to be minus the integral of the natural log of u, just like the natural log of x. Now, that was one of those by part tricks that you could use where you let your u equal, your u would be equal to what? It'd be the natural log of this. 1 plus e to the x. And then your dv would be equal to 1. Okay? So your du would be equal to 1 over 1 plus e to the x. And your v would be equal to x. Woo! I might want to do by parts, though, like you were saying. Because I'm looking at this, and, okay, if I let this first term here be my dv, then that would be e to the x, and that would be e to the x. So it will be minus, all right, so if I do this again, it's going to be e to the x times natural log absolute value 1 plus e to the x. All right, so everything I do after this is going to have a minus in front of it. So it's uv minus the integral of v du, which I can do. All right, can I do that integral because I did it earlier? All right, so let's see what we have. This is e to the x, natural log absolute value of 1 plus e to the x, minus e to the x, natural log absolute value of 1 plus e to the x. And then this is going to be plus the integral of e to the x over 1 plus e to the x. So if we didn't do anything wrong, then this is just equal to the natural log absolute value of 1 plus e to the x. I've never done that integral. So, yeah, that's not good. I don't know. That All right, let's go through this one more time. I just want to go through this integral one more time to make sure I didn't make any mistakes. All right, so here's that's the easy integral. All right. U sub 1 is the tough integral. All right. So I can tell we have this set up correct. I'm very confident in that. It's just the integrating that I'm not 100% sure about. Okay, so if I let u equal this, dv equal this. Oh, I forgot about the negative in front of everything. Do you remember the negative in front of everything? Right here. Which would make that a minus, make that a plus, so that really wouldn't make that much of a difference though. Alright, so I have u, du, dv, and v. U times v minus the integral of v du. Okay. And then from that, I have this minus. So I would just be able to multiply whatever I get times that at the end. Alright, so we got this integral where I let my u equal what I can take the derivative of. Ah, that's where I made my... Look. You didn't catch that? Come on. What's the derivative? It's 1 over u du. Alright. I see what I did. At least I see that part. Alright, and remember, whatever I have, I'm going to take it. I have the negative on the left side. So I have e to the x, ln, absolute value 1 plus e to the x. And then I'm going to have, I have minus uv. So it's minus e to the x, ln, absolute value 1 plus e to the x. And then this is going to be that's going to be 2x, or e to the x times e to the x, which is what I started with. Right? So, and then this is going to be the negative. This is going to be the positive. So I have a plus integral e to the 2x over 1 plus e to the x. Right? So what is this now? The same thing I started off with. So I could make this into an integral equation.
I did with my calculator and got natural log e to the x plus 1 minus e to the x.
Okay. Instead of working it out this way, Could we use long division? Let's see if we could do long division real quick. Because this way has gotten a little, probably more complicated than you would want to do. Even though I am going to let you use the calculators. So if it is something that, and I wouldn't give you an integral this hard. I try to make the homework harder than the test. That way, if you can do the homework, you can surely do the test. But I haven't had anybody come and ask me about this one. So if I used long division, how could I even do this? What would I have to say times e to the x to give me e to the 2x? E to the x. All right. So I'm going to say this times both of those. So if I do that, I have e to the 2x, and then I'll have plus e to the x. You know, so I could have a 0 up here. So then I subtract both of these. That cancels out, and I have negative e to the x. Oh, wow, this became a lot easier. So this is e to the x minus e to the x over 1 plus e to the x. The integral of that, we know how to do the second integral. We know that's a natural log integral. See, I should have done long division. So that's e to the x minus natural log absolute value 1 plus e to the x. I think as long as their signs are opposite, both of those, it'll be the same answer. Is that what the calculator gave you? It gave you the other one minus e to the x. So, oh, there's a minus in front of it. Remember that? So multiply all that by negative 1, and you'll have natural log absolute value 1 plus e to the x minus e to the x. I guess I should have looked at the answer first, because that made it a lot easier. Yeah, long division is the answer there. So now let's go back and multiply our y sub p is going to be equal to u sub 1 y sub 1 plus u sub 2 y sub 2. All right. So what was u sub 1? Or what was y sub 1? Yeah, it was e to the negative 2x. So I'm going to say e to the negative 2x times, it was natural log of what? 1 plus e to the x. Yeah, I might go get a little more room. So that's natural log 1 plus e to the x minus e to the x times e to the, was it negative 2x? 2x plus u sub 2 that's natural log 1 plus e to the x. And then what was y sub 2? E to the, it was negative x. Alright, so you can see what my particular solution is now. So it will be e to the negative 2x minus e to the negative 2x times natural log absolute value 1 plus e to the x minus e to the negative x plus, and you only got to multiply that times one term, e to the negative x times natural log absolute value 1 plus e to the x. So that's our y sub p. So then you just put in our y sub c, and your solution would be c sub 1 e to the negative 2x plus c sub 2 e to the negative x plus. I don't think there's a way to simplify any of that. You might be able to factor a like term out. The only thing I could think of would be to write this term first. So that would be just minus e to the negative x. And then you could factor a natural log of 1 plus e to the x out if you want to make it look a little prettier. You would have plus natural log absolute value of 1 plus e to the x times e to the negative 2x plus e to the negative x. That would be the only way that I could see simplifying. You could also factor out an e to the negative x if you wanted to, but it'll probably take any of those answers. Yeah. That will be one of those. I definitely can't give you anything that hard on the test. But you do have calculators that can help you at least see the answer to a hard integral like that. So if you see an answer like that, then maybe you could think of some other method that we've done, like long division.